Hello, very good morning to all. This is Dr. Anuj Kumar. Welcome to all in this channel. That is कड़ी सलाह डियर स्टूडेंट्स, कैसे आप सभी लोग। और आज हम क्लास पढ़ेंगे कौन सी। आज हम पढ़ेंगे यहाँ पर एलटी गेट टीजीटी पीजीटी मैथमेटिक्स। उसके रिगार्डिंग मैं टॉपिक स्टार्ट करूँगा कॉम्प्रिहेंशन टेस्ट। जो आपको पता होगा कॉम्प्रिहेंशन टेस्ट 2 टाइप्स का होता है। कौन कौन सा होता है आपको पता होना चाहिए। एक लिमिट फॉर्म पढ़ेंगे, एक टर्म वाइज कंपेरिजन पढ़ेंगे और उसकी प्रॉब्लम सॉल्व करेंगे। जो भी इंपॉर्टेंट प्रॉब्लम्स होंगी वो सारी प्रॉब्लम हम क्लास में डिस्कस करने वाले हैं। सो आप लोग क्लास को पूरा देखिएगा सो दैट यू विल गेट द quality content and the concept that will help you to crack this exam and to achieve the goal that you want to prepare for that. Okay, so just get started. सभी लोग क्लास को जल्दी से जल्दी ज्वाइन कर लीजिए। सो कॉम्प्रिहेंशन टेस्ट पढ़ने वाले हैं, जल्दी से आप सभी लोग आ जाइएगा। सो आपको आराम से पता होगा जो मैं पढ़ाने वाला हूँ आराम से पढ़ाएंगे। सो टेंशन मत लीजिएगा। कॉम्प्रिहेंशन टेस्ट है ना, एक बेहतरीन टेस्ट होता है जिससे आप सेज का नेचर पता करते हैं। सेज आपका ऑसिलेटरी है, डाइवर्जेंट है या कन्वर्जेंट है। सबसे पहले हम उसकी डेफिनेशन बताएंगे। हाँ, डेफिनेशन बताने के बाद हम एक टेस्ट करा, पहले हम उसका लिमिट फॉर्म राइट या टर्म बाय टर्म होगा उसको हम सॉल्व कराएंगे। इसके बाद हम कुछ इम्पोर्टेंट जो प्रॉब्लम्स है वो सॉल्व करेंगे राइट। अब आप बने रहिएगा क्योंकि हमारे पास जो आपका मीन्स क्लास होने वाला दैट इज वेरी इंटरेस्टिंग। और इसके बाद आज हम क्लास करेंगे बिकॉज बहुत दिन से क्लास नहीं हुआ है। आप लोग भी कह रहे होंगे पता नहीं मैं कहाँ चला गया, बट डोंट वरी, आई एम हेयर एंड जस्ट आई वाज बिजी विथ माय सम वर्क्स। नाउ लॉट ऑफ वर्क्स आर कंप्लीटेड, rest of are left. I will just completing those by one. So don't worry, I am not going anywhere. I am here to help you. Right. So test for comparison test. Now, you all know that this test will be used to test the nature of the switch and positive term switch. Right? Don't forget to this. This is applicable in case of positive term switch. Now, क्लास देखते हैं किस ज्वाइन हो की है कि कितने लोगों ने ज्वाइन कर लिया और इसके बाद मैं चालू करता हूँ अपनी क्लास। ये कंपेरिजन टेस्ट होने वाला है ना। सबसे पहले मैं आपको डेफिनेशन लिखते जाता हूँ कि क्या कंपेरिजन टेस्ट कैसे लिखते हैं हम, है ना। और फिर हम चीज़ों को बिल्कुल स्मूथ से करने वाले होंगे। देता हूँ। फर्स्ट राइट डाउन फॉर कंपेरिजन टेस्ट राइट। और ये कंपेरिजन फॉर्म जो टेस्ट होगा ये मैं जो टर्म बाई टर्म सीरीज कंपेयर करते हैं दो सीरीज को उसके लिए बताने जा रहा हूँ। लिमिट फॉर्म में मैं बात बताऊंगा। सो राइट डाउन कंपेरिजन टेस्ट कंपेरिजन टेस्ट। Okay, under this write down comparison test, if sigma un if sigma un and sigma vn are positive terms which are positive terms which are positive terms which and k is a constant greater than 0 and there exist m comma there exist m belongs to n. Here n is what? Set of natural number and such that sigma un, okay, no, I'm going to compare the terms, not sigma. Sigma is equal un which is less than equal to k times un, right? And this will happen for all n greater than equal to m, greater than or equal to m. Okay, now so this is sorry, this is vn, same. So write down what we conclude here first, then write down first. Okay, so comparison टेस्ट ये कहता है कि if sigma un, right, and sigma vn, these are two positive term series हैं. ये क्या है? दो positive term series हैं. एंड k ग्रेटर देन 0, k कोई नंबर है, वो भी क्या है? ग्रेटर देन 0 है, मीन्स एक पॉजिटिव नंबर है एंड देयर एग्जिस्ट m बिलोंग्स टू n. m क्या है? नेचुरल नंबर. सच दैट un लेस देन और इक्वल टू vn फॉर ऑल n ग्रेटर देन और इक्वल टू m. n ग्रेटर देन और इक्वल टू m के लिए un क्या है? लेस देन इक्वल टू k टाइम्स vn, राइट? देन sigma vn converges, then sigma vn converges, this implies sigma un converges. Right? And the second part is what? If sigma un diverges, this implies sigma vn is also diverges. So ये है हमारा कंपेरिजन टेस्ट, राइट? इसमें क्या कहते हैं? दो पॉजिटिव टर्म्स से लेंगे un एंड vn, राइट? k greater than 0 and there exists m belongs to n such that un less than or equal to k times vn for all n greater than or equal to m, then sigma vn converges. This implies un converges, right? Second, sigma un diverges if sigma vn diverges. Now आपके पास क्या है? लेट मी टेल यू, un less than or equal to k times vn, and this is what? When for all n greater than or equal to m. Okay, now अब n greater than or equal to m, ये सीरीज है, ये क्या हो गई? लार्जर सीरीज हो गई और ये क्या हो गई? स्मॉलर सीरीज हो गई. ठीक है, तो इसके टर्म्स बड़े हैं इसके un से, राइट? ओके, नाउ सो अगर लार्जर सीरीज आपका ये वीएन क्या है, एक लार्जर सीरीज है, एक बड़ी सीरीज है। अगर लार्जर सीरीज कन्वर्जेट होगा तो उसका छोटा सीरीज भी कन्वर्जेट होगा, दैट इज कॉल्ड। नाउ सेकंड क्या है, अगर छोटा सीरीज यूएन, यूएन क्या है, छोटा सीरीज है, अगर यूएन डाइवर्जेस होगा तो वीएन भी डाइवर्जेस होगा, वीएन भी डाइवर्ज करेगा। ठीक, ये आपका कंप्लीट टेस्ट है। नाउ अब हम बात करते हैं कुछ प्रॉब्लम्स की। क्या, कुछ प्रॉब्लम्स की बात करते हैं, ये नोट कर लीजिए आप। ये आपके पास मैंने इंफॉर्मेशन दे दी कि आप कैसे अप्लाई करेंगे यहाँ पे इस टेस्ट को। नाउ राइट डाउन सेकेंड टर्म। आज प्रॉब्लम लेते हैं, पहली प्रॉब्लम है इस क्लास की। राइट डाउन टेस्ट फॉर कन्वर्जेंस द सीरीज, टेस्ट फॉर convergence, test for convergence the series, convergence the series 1 plus 1 upon 2 square plus 1 upon 3 cube plus 1 upon 4 cube, sorry, 4 to the power 4, and so on, 1 plus 1 upon n to the power n, right? ये आपको करना है, टेस्ट फॉर कन्वर्जेंस ऑफ द सीरीज। राइट डाउन सॉल्यूशन, राइट डाउन, या वेरी गुड मॉर्निंग, राइट डाउन सीरीज। ओके, टेस्ट फॉर कन्वर्जेंस द सीरीज लिखा हुआ है 1 प्लस 2 स्क्वायर प्लस 3 क्यूब प्लस 4 to the power 4। Okay, now so let me write the series again. टेस्ट फॉर कन्वर्जेंस द सीरीज, हमें कन्वर्जेंस चेक करना है इसका। सो 1 प्लस 2 स्क्वायर प्लस 1 अपॉन 3 क्यूब प्लस सो ऑन 1 upon n to the power n plus 1. This is series. Now, its general term can be written as here sigma 1 upon n to the power n, and n is from 1 to infinite. This is general term. So we can write here an, but no. I am just explaining this concept by taking un and vn. So this is our un. Un is equal to 1 upon n to the power. ओके, नाउ आपको अप्लाई क्या करना है, आपको अप्लाई करना है कौन सा टेस्ट, कंपेरिजन टेस्ट। इसके लिए आपको एक सीरीज लेट करनी होगी, सीरीज। सो मैं लेट करता हूँ यहाँ वीएन लेट करता हूँ। क्या वीएन, वीएन हमारे पास है, ध्यान समझिएगा टू द पावर एन, क्या लेट करता हूँ, टू द पावर एन 1 अपॉन टू द पावर एन, ये देख लीजिए 1 अपॉन टू द पावर एन। ठीक है, नाउ अब मैं कुछ सर्टेन करता हूँ कि मैं कैसे मैं लेट कर सकता हूँ। देखो, सबसे पहले आपको पता है एन टू द पावर एन ग्रेटर देन और इक्वल टू लेस देन इक्वल टू द पावर एन। अब ये कैसे, देखो फर्स्ट एन इक्वल टू 1 पुट करोगे तो क्या आएगा, लेट मी टेल यू, एन इक्वल टू 1 पुट करोगे तो क्या आएगा 1 लेस देन 2। ओके, 2 पुट करोगे तो क्या आएगा 2 स्क्वायर एन इक्वल टू एंड 2 स्क्वायर, राइट। तो देखो यहाँ पे क्या आएगा, लेस नहीं है, यहाँ पे क्या इक्वल, यहाँ पे क्या इक्वल 4 लेस, तो यहाँ इक्वल का भी साइन लगेगा यहाँ ना। जब n इक्वल टू आप 3 लेंगे, 3 क्यूब एंड टू पावर क्या आएगा 3 आएगा, तो ये आएगा 27 लेस देन क्या होगा, वेट अ मिनट, मैं जस्ट उल्टा लिख रहा हूँ, ये जो सेज मैंने ये उल्टा लिखा हुआ है, ये टू पावर एन बड़ा होगा एन टू पावर एन पावर एन बड़ा होगा, राइट। नाउ सो नाउ एन इक्वल टू 1, ये वैलिड नहीं है, ध्यान सुनिएगा, बताता हूँ आपको। जब अपन आपने किया एन इक्वल टू 1, राइट, सो क्या आएगा 2 लेस देन 1, नॉट वैलिड, इसके लिए वैलिड नहीं, ठीक ना। फिर एन इक्वल टू 2 के लिए पुट करिए, दैट इज 2 स्क्वायर एंड 2 लेस देन 2। अब ये तो इसमें आएगा इक्वल आ गया, यहाँ पर एन इक्वल टू 2 के लिए इक्वल आएगा। जब एन इक्वल टू 3 पुट करेंगे तो क्या आएगा 2 क्यूब एम लेस देन 3 क्यूब, यस इट विल होल्ड, इट विल होल्ड। एन इक्वल टू 4 पुट करेंगे देन 2 पावर 4 दैट इज 16 लेस देन इक्वल टू 3 पावर 4 दैट इज 81, या होल्ड। So this will hold 2 power n less than or equal to n to power n. When hold? Just see. For all n greater than or equal to 2. 1 पे होल्ड नहीं हो रहा, देख लीजिए, राइट। 2 पे इक्वल का होल्ड हो रहा है, फिर 3 पे स्मूथ चलता है, ओके, ये हो गया। नाउ अब इसको जब रेसी, आप इसको दोनों को आपको पता है कि अगर हमारे पास 3 एक पॉजिटिव क्वांटिटी है, ये सारे पॉजिटिव क्वांटिटी हैं, ठीक ना, चल नंबर है, एंड 3 इज ग्रेटर देन 2 होगा। अगर रेसिप्रोकल करोगे, रेसिप्रोकल तो 1/3 आएगा, 1/2 आएगा, बट इनक्वालिटी किधर लगेगा, इधर लगेगा, राइट, इनक्वालिटी रेसिप्रोकल में चेंज हो जाएगा, ठीक है। सो 1/3 लेस देन इक्वल टू लेस देन हो जाएगा 1/2, ठीक है। ये कब होगा, ये आप रेसिप्रोकल कर सकते हैं जब ये पॉजिटिव क्वांटिटी होगा, तब आप ऐसा कर सकते हैं, नेगेटिव क्वांटिटी पे ऐसा आप नहीं करेंगे, ठीक ना। सो आप अगर रेसिप्रोकल लेंगे तो हमने क्या किया, 1/n लेस देन इक्वल टू 1/n, ये हो जाएगा, ठीक, ये हो गया। अब ये सीरीज हमारे पास क्या है, हमारी यूएन है, राइट, और ये क्या है, ये हम लेते हैं वीएन, राइट। अब आपको पता होगा वीएन, जो सिग्मा वीएन अगर मैं करूं तो सिग्मा 1/n आएगा, और n इज इक्वल टू क्या है 1 टू 5, ये स्टार्ट कहाँ से, 2 से स्टार्ट हो रहा है, राइट। नाउ 2 से कंपेयर कर लेते हैं। सो ये जो भी आएगा, ध्यान समझिएगा, ये आपका हमेशा बड़ा होगा। अब इसका ये सीरीज क्या है, आपके पास है ज्योमेट्रिक सीरीज है, ये क्या है, ज्योमेट्रिक सीरीज है, GOE, इट्स अ ज्योमेट्रिक सीरीज ऑफ कॉमन रेशियो। आप कॉमन रेशियो क्या होता है, कॉमन रेशियो कितना है इसका, इज इक्वल टू 1/2 विच इज लेस देन 1, राइट। और मैं आपको बता दूं, ये कन्वर्जेंट होता है, अगर कोई भी ज्योमेट्रिक सीरीज है, जीपीएच ज्योमेट्रिक प्रोग्रेशन बोलते हैं, या सीरीज पर सीरीज मैं यहाँ डील कर रहा हूँ, तो सीरीज आएगा, ठीक। ज्योमेट्रिक सीरीज अगर कोई भी कॉमन रेशियो 1/2 लेस देन 1 होता है, तो सीरीज हमारा क्या होता है, कन्वर्जेंट होता है, ठीक। जब आपका वीएन कन्वर्जेंट हो गया, क्या हो गया, वीएन इज कन्वर्जेंट, वीएन क्या हो गया, इज कन्वर्जेंट हो गया, मतलब बड़ी सीरीज कन्वर्जेंट हो गई, तो छोटी सीरीज मस्ट बी कन्वर्जेंट। सो दिस एम्प्लाइज UN is also convergent, is also convergent, वी एन इज आल्सो कन्वर्जेंट, राइट। बस सॉल्व हो गया प्रॉब्लम आपका। देखिए, तो इस तरीके से आपको खुद ही मतलब एक स्विच ऐसे स्विच करना पड़ेगा कि जिसके लिए इनक्वलिटी होल्ड हो। और मैंने आपको आपके पास एक दिया मैंने स्विच, ये इनक्वलिटी होल्ड कर रहा था। तभी देखो इसमें लिखा है, आप देखिए कमेंट, कि हो सकता है शुरुआत में इनक्वलिटी ना होल्ड करे, बट एन ग्रेटर देन इक्वल टू एम के लिए होल्ड करना पड़ेगा। तो वही आपने ये लिया टू पावर एन, ये इक्वल टू 1 के लिए होल्ड कर रहा है, 1 के लिए एन इक्वल टू 1 के लिए नहीं होल्ड कर रहा था, बट एन ग्रेटर देन इक्वल टू 1 के लिए होल्ड कर रहा था, जो मैंने लिया। हम्म, बोलो। ओके, नाउ राइट डाउन नेक्स्ट प्रॉब्लम। प्रॉब्लम नंबर 2, टेस्ट द सीरीज sigma e to power minus n square converges. Write down solution. Now, अब ये सीरीज है आपके पास, टेस्ट द सीरीज e to power minus 1 square is convergent. Hello. Okay. Now, so we have very well famous that is called inequality. Now see, e to power x greater than x for all x greater than 0. ऐसा होता है नहीं, आप चेक करके देख लीजिए। इफ यू आर नॉट सेटिस्फाइड विद दैट, so you can take here x equal to 1. At x equal to 1, we have what? E to power 1 greater than 1. Now the value of e to power 1, that is 2.72 something. This must be old. Now at x equal to 2, you can take, so this is e square means something 4 plus, right? And this is 2. Again hold. So this inequality hold e to power x greater than equal to x greater than x for all x greater than 0. Right? Okay. Now how can you understand this? I am just showing you by taking graph. Okay. Now you all know the graph of this y is equal to x. This. So y is equal to x, this graph, and this is our x, and this is y, and this is y. Okay. Now next, y is equal to e to power x graph, you all know. This is what? Okay. When x equal to 0, y equal to 1. Okay. This is x. Okay. Now you can see this is r e to power x and this is x. Always greater than x. Always greater than x. Okay. Now I'm just going to compare. Now put here x is equal to n square. I'm just going to adjust it according to our problem. So you can write e to power n square greater than n square. And you know what? E to power n square both are positive quantity. Both are positive quantities, so we can take reciprocal there and the inequality will change. Equality will reverse, right? So we can write this is less, okay? And what? E to power minus n square, okay? And 1 upon, sorry, take the reciprocal, so we have this reciprocal and n square, that is what? 1 upon n square greater, and this is e power n square will be less. We can do why these are the positive quantities. E power n square. Okay. Now this is minus e power minus n square less than 1 upon n square. This is our un now. So we can take un is equal to e power minus n square and vn is equal to 1 upon n square. And this 1 upon n square is convergent. This 1 upon n square is convergent. I am writing a sigma 1 upon n square is convergent. Sigma 1 upon n square is convergent to what? Go through P series test. P series test. Right? Sigma 1 upon n to the power p is convergent when p greater than 1. P greater than 1 is convergent. So here p is equal to what? P is equal to 2 and 2 greater than 1. That's why the series Vn is equal to 1 upon n square is convergent. And if this series is Vn convergent, that this series even must convergent by using which test? Here you can use comparison test. So this is all about this problem. I just go through the concepts and the petrol graph as well. I hope so you understood all the things. If you understood, just give thumbs up so that I can proceed to the next problem. Okay. Now I'm going to move next problem. That is our problem number 3rd. Now, test the for convergence the series. Test for convergence. The series test for convergence the series sigma n equal to 2 to infinite 1 upon log n. 1 upon log n. Okay, now see. Write down solution. Write down solution. Okay, now see. So, yeah. Now this problem we have here. Let me record. Okay. Okay. Test for convergence the series. Now the series is given to you. N is equal to 2 to infinite 1 upon log n. 1 upon log n. Okay. Now I'm just, we take here un is equal to 1 upon log n. Okay. Now I'm going to consider the next is that we know the identity, that is what? Log x less than x when x for all x greater than or equal to 2. This is identity. Now how? Just see. I'm taking x greater than or equal to 2. So this is y is equal to x. This is y equal to x. Graph. Okay. And also you have log x. The graph of log x will lie that there. This is our log x. I am talking about the natural log. Base is exponential means e. Okay. Now you can see here this x greater than log x. for all x greater than or equal to 2. Why? Because log 1 is 0 and 1 is 1. Okay, now see. So in case of n, we can write here log n less than n for all n greater than or equal to 2. This is what. Write down next one. Take the reciprocal. Okay. Log n is positive quantity. You can see the graph. This is above x-axis and y equal to x is also when n greater than or equal to 2. You can just treat here n greater than or equal to 2. Okay. Okay, now see. So we can write here 1 upon log n, this is, and 1 upon n. Both are positive quantity, we are taking this. And this is what? Or you can write here, or 1 upon n less than 1 upon log. So un is equal to this, and we can take vn is equal to 1 upon. Vn is equal to 1 upon n. Right? Now, here the series 1 upon n, vn. Vn is equal to 1 upon n. That is called a harmonic series. A harmonic series. A harmonic series. This is called harmonic series, right? And you can take if we have series sigma 1 upon n to the power p, right? P is equal to 1, so this is divergent. This is diverges. So this implies, already I have told you, go through the comparison test. Let me tell you. Let me show you again. The first slide, yeah. If Vn is divergence, means the smallest is divergent, the largest is also divergent. Okay. Now, so from this we can write 1 upon log n, that is what un diverges. Un diverges. Okay. So this problem done. Now go to the next problem. Problem number 4. We have here 1 upon n square log n. 1 upon n square log n. Okay, now see. Test the series. Test for convergence the series. Test for convergence the series. Sigma 1 upon n square log n. Okay, test for convergence series. Sigma 1 upon n square log n. So how we have to solve? Let me tell you. Just tell me. Okay. So you watch. Not. If you want more problem, dear students, so you can follow my Facebook page, that is called Maths by Dr. Anuj Kumar for CCR using it. There are a lot of problems I have loaded daily. You can go through and test yourself. Okay. Now, write down solution here. Okay. Now again we have to compare. What we have? We have 1 upon n square log n. This is that I am going to use to check the nature. I will use again here. Which test is? I am using a comparison test. Now write down un. Un equal to we have 1 upon n square log n. And just I have told you, means you can see here what log n quantity. This is what less than n for all n greater than or equal to 2. Okay, means log n positive quantity. So we can write here what? Just see. Okay, now we can write here 1 upon n square log n less than 1 upon n square. Why? N is log n is a positive quantity. So n square positive quantity is always less than 1 upon n square. Right? When the denominator goes high, the overall quantity will less. And this is holding for n greater than or equal to 3. For n equal to 1, this is not defined because log 1 equal to 0, it goes infinite. N equal to 2, yeah, because log 2 value is I think 0.3010 something, and so it goes to less. Right? That's why for n equal to 2, this is also not defined. The means this inequality will not hold for n equal to 1, n equal to 2. Go through value of log 2, that is 0.3010, which is not hold, and also for n equal to 1, log 1 equal to 0, again not hold. Right? So you should start this inequality by taking n greater than or equal to 3. By taking n greater than or equal to 3. This is what we have. Now, so we have found here what? We have found that here Vn is equal to 1 upon n square. 1 upon n square. Now, go to P series test, we have, if we have 1 upon sigma 1 upon n to the power p, the series stack convergent, the series this series is convergent when p greater than 1. Okay, so sigma 1 upon n square is convergent, is convergent. Why? P is equal to 2, 2 greater than 1 is convergent. Okay, this is convergent. Hence the smaller series, that is sigma 1 upon n square log n, also converges. Also converges. Okay, now this problem we have been solved. Now, so these are the some problems that I solved by taking terms comparison. Now one more problem, one or two we have more problems. Then we will write here a comparison test of limit and the limit form, right? Problem number 5. Test for convergence the series. Test for convergence the series. Test for convergence the series 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon n factorial. Okay, now test for convergence the series. This is a problem we have here. No. Okay, now write down. Here we have. You can write here 1 upon n factorial. This is series 1 plus 1 upon 2 factorial plus 1 upon 3 factorial plus so on 1 upon n factorial plus so on. This is the series 1 upon n factorial. So we have to check the nature of the series. हमें इस series का nature check करना है convergence divergence. Okay. Now we all know what n factorial greater than 2 to the power n minus 1 or n greater than equal to 2. Now we can check here n for n equal to 1. For n equal to 1 we have 1, right, and greater than 2 greater than 2 to the power and 0 1 to the power 1 minus, right. So 1 greater than 1 to the power 0, that is 1, not possible, not possible. Okay, that's why I didn't put here n equal to 2. Okay, now for n equal to 2 you can check, that is 2 factorial, greater than 2 to the power 2 minus 1, n equal to 2. Okay, so again 2 greater than 2, not possible. Yes, not possible. So we have to take here this. Okay, sorry, n greater than 2. Now for n equal to 3 you can take 3 factorial, that is 6 and square. So 6 greater than 2 to the power 3 minus 1, that is 2 square 4. Yes, this is. Similarly, put n equal to 4, 2 to the power 4, that is 16, and 4 factorial, that is 24. Is always our problem. Clear? So, this comparison test is not for that you have to compare the terms from the first term. Right? You can take this inequality may hold after taking some finite terms, right? You can just means leave, yes, some finite number of terms, no problem. But the nature of the sieve will remain same, right? Now you can take n greater than to this. Now you can n factorial and to the power n to the power n minus 1, both are positive quantities. Both are positive quantities. You should take a reciprocal and the inequality will get reversed. Yes, see how. So this is you can write here 1 upon n factorial less than 1 upon 2 to the power n minus 1 for n greater than 2. If we add finite number of terms, if you remove finite number of terms from the series, nature of the series will not change. If the series is convergent, then the series will remain convergent. If the series is divergent, the series will remain divergent, no problem. If you add or remove finite number of terms, right? No. So now here un. the given series 1 upon n factorial and the Vn is equal to 1 to power 2n minus 1. Okay, now see. The series sigma Vn 1 upon 2 power n minus 1 and n greater than 2. N greater than 2. So n equal to, let me tell you, yeah, n greater than 2. So I am starting at 3. So n equal to 3, you have 2 square, n equal to 3, n equal to 4, 2 cube, n equal to 5, 1 upon 2 power 4, and so on. Here common ratio r is equal to 1 by 2. Okay, and this is a geometric series, geometric progression you can say, and the series will convergent if the common ratio mod of r less than 1. If mod of r less than 1, the series is convergent. So this series is convergent, but this is geometric progression of common ratio less than 1. So the original series un, so this implies un is equal to 1 upon n factorial, also convergent. This is also convergent. This is also convergent. Done? Okay, now write on next problem. Problem number, let me tell you, yeah, 6. Problem number 6. Test for convergence of the series. Test for convergence the series. Test for convergence the series sigma n equal to 1 to infinite 1 upon 3 to the power n plus x, right, for all positive values of x, for all positive values of x, for all positive values of x. For all positive values of x, right? Now, so now test the nature of the series. Test the nature of the series for convergence the series sigma n equal to infinite 1 upon 3 power n plus x for all positive values of x. Now write down sigma. Okay, we have n equal to 1 to infinite 1 upon 3 to the power n plus x. This is the power. So we have un un is equal to 1 upon 3 to the power n plus x. Okay, now see, we all know what this 3 to the power n plus x greater than 3 to the power n when n greater than or equal to 1. Yes? And for n equal to 1, this is also holding. Right? Why? Because x greater than 0 for all positive values. Okay? Now, so we can write here what? Less than. Take the reciprocals, both are positive quantities, so we can do it. 1 upon 3 to the power n plus x. Okay? Now, here Vn is equal to what? Vn is equal to, this is h 3 to the power n. This is our Vn. Now, Vn h from n equal to 1 to infinite. So you can write sigma Vn. Sigma Vn, first put n equal to 1, 1 upon 3, 1 upon 3 square, 1 upon 3 cube plus, 3 cube plus so on. And this is geometric stage. This is a geometric stage of common ratio r equal to 1 upon 3, which is less than 1. So Vn, this implies Vn converges, and hence Un converges. Now this problem is solved. I think प्रॉब्लम अच्छा था तो मैंने सॉल्व कर दिया आपके. नो प्रॉब्लम. यस, नो प्रॉब्लम, डन. नाउ limit form of comparison test we have. Now write down limit form of comparison test. नेक्स्ट है हमारे पास लिमिट फॉर्म ऑफ कंपैरिजन टेस्ट. Limit form of comparison test. Let me tell you. Let sigma un and sigma vn be two positive term series. Be two positive term series. Be two positive term series such that limit n tends to infinite, un upon vn is equal to l. Un upon vn equal to l, and l is a finite quantity. L is a finite quantity. L is a finite quantity, but not zero. But not zero. But not zero. Then sigma un and sigma vn converge or diverge together. Converge or diverge together. This is limit form of convergence test. This is what? Limit form of convergence. Correct. Okay. Well, is a finite quantity. Now you can see, and let us solve some problems. One remark is very important here. Remark. Here the remark is what? Remark is what here? If L is equal to 0, if L equal to 0 or infinite, if L equal to 0, if L equal to 0 or infinite, then the test may not hold good. Right? This test will hold good when L is a finite quantity but not 0. Anyway, you have the value of L, that is 0 or infinite, the test may not hold good. This is the point that you have to keep in your mind. Okay, now just see here. Suppose I'll explain this through one example. Now we have here random 5 form relational. If we have un is equal to 1 upon n square and vn is equal to 1 upon n. So write down limit n tends to infinite, un is equal to v. So this is limit n tends to infinite, un upon v, un 1 upon n square, and vn is equal to 1 upon n. That is limit n tends to infinite, n upon n square, that is limit n tends to infinite, 1 upon the n is equal to 0, n equal to 0. Now it means what? 0, but it means both the series have same nature, according to you. Both series have same nature, but see nature, even each convergent, you can see here, even each convergent by PC test, even each convergent by PC test, but 1 upon n, that is Vn, is not convergent, but Vn is not convergent. But Vn is not convergent. Okay? Similarly, if we change here, now, next case we have Un is equal to 1 upon n and Vn is equal to 1 upon n square. Okay? Now just find the value of limit n tends to infinite Un upon V. That is limit n tends to infinite Un, that is 1 upon n, and Vn, that is 1 upon n square. If we are going to calculate here, you have limit n tends to infinite, that is n, but n tends to infinite is n. So in this case, you know what? They don't have both same nature. Why? Here Un even is convergent, but what? Vn, sorry, even is divergent. Even is divergent, but Vn is convergent. That's why if R equal to L equal to 0 infinite, this test may not hold good. Hence proved. Hence proved. Okay. Now move next problem. Okay. Now, so solve the problems based on this. Okay. Now, let me drink water. Just give me please once, you can say 1 minute, 30 seconds. I'm coming. Okay, now. Okay, so write down problem here. We have test for convergence the series. This is our problem number, let me tell you. Yeah, problem number 7. Test for convergence the series. Test for convergence the series. Test for convergence the series 1 upon 3 into 7 plus 1 upon 4 into 9 plus 1 upon 5 into 11. Okay, plus so on. Plus you can write one more term 6 into 30 plus so on. And this is the problem that I have to solve for all of you. Okay, test for convergence the series. Test for convergence the series. Test for convergence the series. Okay, now. So we have the series, let me write 3 into 7, 4 into 9 plus 1 upon 5 into 11 plus 1 upon 6 into 30 plus so on. This is it. Now I have to solve this problem by using ratio solve. At this stage that is called completion test. Okay. Write down it's a general term union. I think you all know how to write general term. Just this is 3, 4, 5, 6. Now add it. 3, 4, 5, 6 and so on. Write down general term an is equal to what? A plus n minus 1 into d, that is common difference 1. That is common difference 1. So this is 3 plus n minus 1 and this become what? N plus 2. You can check here, it's n plus 2. So general term 1 upon n plus 2. And next we have 7, 9, 11 and 13. Again, this is the arithmetic progression, random general term. An is equal to a plus n minus 1 into d, that is 2. That is 2. So 7 plus 2n minus 2, that is 2n plus 5. So that is 2n plus 5. This is our unit. Now, so how to take Vn? This is the question mark to all of you. Nothing hard to do. This is a rubber that I'm going to tell you. I'm talking here Vn is equal to 1 upon n square. When you can put, sir, how? Yes, sure. You can take, let me tell you the rough sum rough. You can just write here, say 1 upon n plus 2, 1 plus 2 take common here, and n square. So this becomes 1 plus 2 by n and 2 plus 5 1. So this is n square into 1 plus 2 by n plus 5, 2 plus 5. So that's why we are taking here Vn is equal to 1 upon n square. This is the example. This is the one way to select Vn. Okay. Now find out limit n tends to infinite un upon v. Limit n tends to infinite un upon v. Un is what? 1 upon n plus 2. Let me check. Yeah. N plus 2 into 2n plus 5 upon Vn, that is 1 upon n square. And you have to solve this. Yeah. Just see how. Okay, so this can be written as limit n tends to infinite n square upon n plus 2 into 2n plus 5. This can also be written as limit n tends to infinite. Take n common from these two factors, n plus 2 and 2n plus 5. That is n square will come out, and one factor we have 1 plus 2 by n, another factor will be 2 plus 5 by n. Okay. Now here what? N tends to infinite. N tends to infinite. This is cancel out. So 1 upon 2 upon n, that is 0. 1 plus 0 into 2 plus 0, that is 1 upon 2, which is not 0. Which is not 0. Hence both series have same nature. Hence both series have same nature. Same nature. दोनों क्या नेचर सेम है. ओके, बट यू कैन देन Vn, V sigma Vn is equal to sigma 1 upon n square is convergent by P test is convergent by P series test by P series test is convergent by P series test, and this implies sigma Un is also convergent. Is also convergent. Hence this problem solved. This problem is solved. I think you enjoyed the solution. Okay. Problem is solved. Now, I do next problem here. Test the test for convergence the series of the next term. Test for numbers 8. Test for convergence. Test for convergence. Test for convergence the series whose nth term is nth term is Un is equal to under root n plus 1 minus under root n minus 1 upon n. Write down solution. Write down solution. Now, test for convergence the series whose nth term is Un is equal to under root n plus 1 minus under root n minus 1 upon n. Okay, and this is the problem. Test for convergence the series whose nth term is this. Yes, now see. So even is given to you what? Even is equal to under root n plus 1 minus under root n minus 1 upon n. Okay. Now multiply and dividing by under root n plus 1 plus under root n minus 1. Okay. Now this is you can treat here a plus b, a minus b and a plus b. So this becomes a square minus b square, means n plus 1 minus n minus 1. No problem? Here, no problem. If you have any doubt, you can ask me. Okay? Upon we have n into under root n plus 1 plus under root n minus 1. So now you can solve this. This is n minus 1 cancel. N plus 1, that is 2 upon n. Okay? Test for convergence thus see which n term is this. Okay, now see. Even now I am taking here Vn. Vn is equal to 1 upon n to the power 3 by 2. You can put how? Sir, let me tell you. You can, this is our un, 1 upon n. Take n to the power under root n common. So we have under root 1 plus 1 by n plus under root 1 minus 1 upon n. This is 1. So this is what? 1 upon n to the power under root n, that is 1 upon n to the power 3. This is our Vn. This is the trick to select here Vn. Now find limit n tends to infinite even upon Vn. That is limit n tends to infinite even upon Vn. Even upon Vn. Even is what? 2 upon n within bracket under root n plus 1 plus under root n minus 1. Upon Vn is what? 1 upon n to the power 3 by 2. Let's solve it. Limit n tends to infinite even upon Vn. Even upon Vn. So we have 2 into n to the power 3 by 2 upon n to the power 3 by 2. I have taken common here, right? So this converts as under root 1 plus 1 upon n, okay, and plus under root 1 minus 1 upon n, okay. So this n to the power 3 and to the power 3 cancel out. Okay, so we have what? Limit n tends to infinite even upon Vn is equal to 2 upon under root 1 plus 1 upon n minus under root 1 minus 1 upon n. But n tends to infinite, okay, this is our plus. That's why I'm thinking this has become 0, right? So n tends to infinite, this 1 upon n tends to 0 and yeah, I forgot to write, right? So this become 2 upon under root 1 plus 0 plus under root 1 minus 0. After taking n tends to infinite, we have 2 upon 2 under root 1 that is 1 1. So 2 plus 2 that is 1 does not equal to 0. This is a finite quantity but is not equal to 0. So both series have same nature. So this implies both series have same nature. Both series have same nature. Okay, even and Vn both series have same nature. So this implies even each. Now what? Un is convergent. Un means the given series is convergent. Why? Since Vn is convergent, since Vn is convergent by P series test. By P series test. Why? Because n equal to 3 by 2 greater than 1. So this is convergent. But the problem was amazing. I explained to you. And if you are still any doubt, you can just tell me. I will tell you the answer. Anything what you need from my set, I will try to make you understand. Okay, now this one. Okay, so you solve problem. Now one more problem, the last problem I'm going to solve for all of you. Problem number 9. Yeah, the series, now write down, the series 1 upon under root n plus under root n plus 1. Okay, diverges. You have to show that the series 1 upon under root n plus under root n plus 1 diverges. So write the solution. Write the solution. The series 1 upon under root n plus under root n plus 1 diverges. Right? So see how this is divergent series? No. Given to you what? I am writing un, sigma un, right, is equal to sigma 1 upon under root n plus under root n plus 1. This is the series. So first I am taking here, this is our un. Un is equal to 1 upon under root n plus under root n plus 1. This is our general term. Okay. Now what is fair Vn? This is the question mark. That's the question mark. So I am taking here Vn is equal to 1 upon under root n. You just tell me, you can put the question how, just tell me. I'm sorry, I'm doing it. So this is our under root n plus under n plus 1. ये ऐसा लिखा है आपके पास. आपने क्या किया? हमने क्या किया? अंडर रूट n कॉमन ले लिया. तो क्या आया? 1 अपॉन 1 प्लस अंडर रूट 1 प्लस 1 अपॉन n. ये जो 1 अपॉन अंडर रूट आया, ये हमने क्या लिया? Vn. Vn is equal to 1 upon under root n. Okay. Now use a comparison test. So limit. Let me record the video so that to share a lot of students that they are waiting. So limit n tends to infinite. Un upon v. Un upon v. So limit n tends to infinite. Un is equal to what? We have under root n plus under root n plus 1 upon Vn is 1 upon under root n. Let's simplify it. Limit n tends to infinite. We have under root n upon under root n plus under root n plus 1. Let's simplify. Okay. So limit n tends to infinite under root n upon, take common under root n from denominator, we have 1 plus under root 1 plus 1 upon n. This under root and under root cancel out from numerator and denominator. You have limit n tends to infinite 1 upon 1 plus under root 1 plus 1 upon n. N tends to infinite, that is 1 upon 1 plus under root 1 plus 0, that is we have 1, that is not equal to 0, means non-zero quantity. So hence the comparison test, this implies what? Un and Vn, Un and Vn both have same nature, both have same nature, दोनों कैसे सेम नेचर के U1 and Vn हैं, but what Vn is equal to 1 upon n to power 2. Here you can say 1 upon under root n. Its divergent is by P series test. By P series test. By P series test it is divergent, and you can take here 1 upon n to the power p. Right? Diverges when p less than or equal to 1. Divergent. Right? So this simple, hence Un is equal to 1 upon under root n plus under root n plus 1, and this is the series. So take sigma is also divergent. So now today I complete here comparison test. I solve the problems to get the better understanding. If still you have doubt, you can just reach out to me. I'll help you to come over these problems. So thank you all of you. God bless you all. Have a good day. Meeting you tomorrow. I have next. Okay. With next concept, I will take another test, a Cauchy's test, a ratio test. I will explain from bottom to top. Okay. Thank you once again.